Welcome to This Explainer. Today, we're tracking the wild, fascinating, and honestly rigorous journey a piece of furniture takes just to survive the gauntlet. We're going from a fragile little sketch all the way to a mass-manufactured reality. We're going to unpack the intense process of optimization, the endless trial and error, and the literally brutal physical testing required to bring a simple concept to life. Let's get into it. Okay, so here's our roadmap for today. We'll be hitting 4 crucial phases. First, moving from sketch to concept. Second, the digital CAD transition. Third, prototyping and physical testing. And finally, navigating standards and safety. All right, phase 1, from sketch to concept. So, as the legendary architect Le Corbusier perfectly put it, the raw act of just putting a pen to paper is the absolute fastest way to interrogate an idea's potential. He famously noted that in a drawing, there is less room for lies. It's the most accessible tool a designer has. It's fast enough to keep up with a racing mind, but sensitive enough to capture the nuanced beauty of a really complex detail. You can really see this evolution early on. We usually start with these rapid, highly interpretive sketches to capture a feeling or a specific function. But eventually, as that concept inches closer to reality, we have to transition to hyper-precise, totally unambiguous technical definitions. If a designer is going to communicate with a manufacturer, they absolutely must follow international drafting conventions. That way, a model maker halfway across the world knows exactly what to build without any guesswork. Now, counterintuitively, those early, totally inaccurate sketches, they're actually a really good thing. Drawing is interpretive, it's inexact, and its wonderfully ambiguous nature is exactly what sparks new ways to solve physical problems. It suggests completely unthought of constructions, weird materials, and new aesthetics. Those inaccurate drawings make the impossible seem possible for just a moment, pushing the designer to innovate before the strict, unforgiving laws of physics shut them down. Moving right along to phase 2, the digital CAD transition. So the crucial takeaway here is that choosing your software basically acts as a strict filter for your idea. Each program gives you specific engineering superpowers, but also distinct limitations. For example, 2D drafting is fantastic for accurate layouts, but solid modeling is where you actually get exact, manufacturable geometric forms. Need complex organic curves? Well, you jump over to surface modeling, which uses splines with variable rates of change instead of rigid dimensions. But, and this is a big but, beware of polygon modeling. It's great for a quick visual, sure, but it describes forms through surface approximation. That means you get faceted faces instead of pure curves. It is simply not accurate enough to send over to a CNC router for actual manufacturing. Okay, phase 3, prototyping and physical testing. To really proofread a concept, designers have to rely on a pretty grueling step-by-step physical process. Because, let's be honest, relying solely on software is a surefire way to create furniture that utterly fails to support a human body. You have to move from rough cardboard mock-ups up to one-to-one scale test rigs and all the way through to CNC machined prototypes. There is literally no software substitute for just sitting on a physical object to see how it interacts with the human spine. Take the incredible hands-on approach of designer Stefan Diez, for example. For his renowned Houdini chair series, he didn't just jump straight into expensive manufacturing. No, he physically built the initial concepts out of everyday cardboard and wood. He crafted these one-to-one models based on measured drawings just to deeply understand physical flow and the volume of the chair before ever touching heavy machinery. Because the reality of the workshop is messy, hands-on work. The complex cramping and gluing procedure for that Houdini prototype required legs machined to provide an interference fit with just the exact right tolerance for the glue. Manually testing these early joints, building the bracing jigs, and figuring out the actual sequence of assembly, it saves a massive amount of time and money before you even think about considering expensive production tooling. And this brings us to a bit of a dramatic cliffhanger in our product's journey. Okay, we know the shape works, we know the joints fit, but when we move to the final materials, like advanced plastics, is it going to snap right in half under a person's weight, or will it survive? Well, boom, here's some visual proof for you. To test the Mito chair, which was developed using a really innovative thermoplastic called Ultradur, designer Konstantin Grichik and his team didn't just trust a digital analysis. Oh no, they dropped a literal 500-kilogram block of steel that is over 1,100 pounds directly onto the chair just to test the plastic's performance. And you know what? The chair actually survived. It just goes to show that extreme, almost violent physical trials are absolutely necessary to validate a new material. But on the flip side, sometimes the physical test reveals a fatal flaw that forces you to start completely over. The intricate vegetal chair, designed by the Barula-like brothers, took 4 grueling years of complex development. They prototyped the seat shell using vacuum-cast high-density polyurethane, but after all that massive expense and progress, once the designers actually sat on the physical prototype, they realized it was just too uncomfortable. The intersecting branches overlapped way too deeply. So they had to swallow their pride, head back to the drawing board, and create hundreds of variations using simple paper models until they finalized a composition that was actually comfortable. Which brings us to our final phase, Section 4, Navigating Standards and Safety. Now, these aren't just boring legalities. Organizations like FIRA in the UK and BIFMA in the US use brutal performance testing rigs, like massive rotational machines. They subject the furniture to prolonged, extreme use just to ensure a product won't degrade, snap, and, spark a massive lawsuit down the line. Because at the end of the day, a retailer selling a dangerous product is entirely liable for its failure. Okay, so let's break down exactly what they're testing for before a product is legally allowed in your home. It's a seriously exhaustive list. They run adhesive testing to make sure bonds won't fail and cause a total structural collapse. They test for formaldehyde emissions, strictly limiting those tiny amounts of chemical gases that man-made timber boards can release over time. They test foams and fabrics for flammability. They test how well a wood board can hold a single screw. And they even bring in expert ergonomists to ensure your office chair won't cause severe muscle strain or long-term damage. It's intense. And context completely changes the legal stakes here. A chair designed for a typical domestic environment, like your cozy living room, faces a standard level of risk. But contract furniture environments, places like schools, hospitals, or high-risk facilities like prisons, those require significantly more complex and strict regulations, simply because the potential for abuse, accidents, or injury is exponentially higher. 45 to 65 millimeters. I really want you to remember that number. That is the exact legally required gap between the bars of a child's cot, a maximum of 2.38 inches. Why that specific number? Because accident analysis and rigorous testing prove that this exact dimension prevents a claiming child from slipping through, getting trapped, and suffocating. Plus, the top rail has to be a minimum of 500 millimeters above the mattress so they don't fall out. This just proves that precise design standards aren't just annoying bureaucratic guidelines. They quite literally save lives. So we've gone from a messy, ambiguous sketch right through the strict digital filter of CAD into the brutal physical reality of 500-kilogram weight drops, and finally through the rigorous legal gauntlet of safety standards. The next time you sit down, I want you to ask yourself, how many thousands of unseen decisions, relentless trials, and physical failures did that seemingly simple chair have to survive just to safely hold you?